This is the screencast for section 1.2, example 3, domain and range. You touched on domain and range a little bit in Algebra 1 and Algebra 2. In the past, my students have told me that this is the most difficult part of this section, is understanding domain and range. I'm going to do the best I can to explain to you different ways to look at finding domain and range. Well, first of all, what is domain and range? Well, we can use D and R to represent domain and range, respectively. The domain of a function represents all of the values in the input. So in other words, what x values you can plug into the function without creating an error or an undefined or something like that. The range then is all the values that result from plugging in those x values. So the y values that are being used in the function. So example 3, finding the domain of a function. Directions say find the domain of each of these functions. We're going to look at both an algebraic and a graphical way to find the domain of these functions. The reason I'm looking at both algebraic and graphical is because I want to make sure that what I'm thinking about is also represented by what the calculator is showing me. Alright, find the domain of these functions. A, f of x equals the square root of x plus 3. Well, I know I can't take square roots of negatives. I can take the square root of 0 and anything positive, which tells me that inside the square root has to be 0 or bigger, which means x can be -3 or higher. So I'm going to put down here my domain is -3 to infinity. Now, if you don't know interval notation yet, interval notation, the bracket means this includes -3, and then we go all the way out to infinity where we have parentheses. A bracket means you actually do include that number. A parentheses means you include everything really close to that number. You'll never be able to land on infinity, so infinity has a parentheses. In this situation, I have a bracket next to -3 because -3 is a number I can plug in here. I can take the square root of -3 plus 3, which is 0. Now, if I look graphically at this function, the square root of x plus 3 looks like this, and I think that my calculator shows me a value right there. But this wasn't graphed by my calculator, this was graphed by the book. We can make that exact picture appear on our calculator. So I'm going to clear out my y1 and y2. I'm going to put in the square root of x plus 3. And now these numbers under here give me my window, x min, x max, y min, y max. So x min -10, x max +10, no problem. Then y min -4, y max +4. Graph. Now my calculator looks exactly like the picture that the book showed me, just so I can get a better idea of what's going on with the numbers here. If I hit trace, I can trace very close to -3, but I want to know if I can actually land on -3, or is that like the last value missing? I can hit -2.99999 something. Can I actually get to -3? So if I hit -3, enter, I do see that there is a y value that comes out there, -3, 0. Therefore, -3 is, I was correct, -3 is included in my domain. I use a bracket. Now, over here, part B, g of x is the square root of x over x minus 5. Well, this is really hard to see on the book's example. Does the function end right here? Can I not plug in -1? Well, I'm looking back at the algebraic version, and I see square root of x. Oh yeah, square roots. I can't take negatives. I can't take the square root of negatives. So that means I do have to start at 0. But can I actually plug in 0? Well, the square root of 0 is 0, divided by 0 minus 5. 0 divided by -5 is 0. So I do believe there is a point right there. Now what gets confusing is this vertical line right here. If you remember from the calculator error portion of section 1.1, that vertical line is not supposed to be there. So I'm going to go into my calculator, and I'm going to put my numerator in its own set of parentheses, second square root x get out of that square root and hit your close parentheses for your numerator, divided by new parentheses for the denominator. Second, nope, no second involved, just x minus 5. Graph. Now my calculator is updated, so I can see that there is not supposed to be a vertical line there. But just to check, let's see, 1, 2, 3, 4. That vertical line would be at positive 5, which makes sense because positive 5 makes the denominator 0, which would create an error. So I'm going to hit trace 5, and I can see that there is no y value there when x equals 5. So 5 is not in my domain. I can plug that in, but there is no output that belongs with it. Therefore, I actually cannot plug it in. It would cause an error. So my domain for part B, we started at the value 0, which was okay to plug in. Matter of fact, I'll check that. Yep, 0, 0, no problem. I have an output y value. Went from 0, going from left to right. We went up to 5, but did not include 5. So I have to put a parentheses next to 5 because 5 gets left out of the domain. The actual number 5. 4.99999, fine. 5, not fine. And, so union, I'm going to start back up just after the value 5. This piece right here means I have values in my domain after 5. X values I plug in that get y values, and I go all the way out to infinity. Part C, a of s equals the square root of 3 divided by 4 times s squared, where a of s is the area of an equilateral triangle with sides of length s. Maybe you recognize that. I have a square root in this problem, but the square root is not around my variable. My variable is just being squared. So any number can be squared in the entire world. Any real number can be squared. So for this domain, I'm going to put in negative infinity to infinity. Again, your infinities have parentheses because you can't actually land on infinity. You can't actually count infinity. So to go back, there are 3 ways to look at finding domain. What numbers can I algebraically plug in without getting an error? What does my calculator show me that has what x values does my calculator show me that have y values belonging to it? And then the third way that I look at it is, if I were to take the x-axis, because the domain are the x values, if I were to take the x-axis and draw lines away from it, where would my function, where would these lines hit part of my function? Well, starting at 0 and over, for example A. For example B, I'm not hitting any function here. I don't hit function until 0. I start at 0. Then I hit function, hit function, hit function. Now not at 5. At 5, I can draw a line that doesn't pass through the function at all. So that's why I had to leave out 5. It did not have a y value that belonged to it. But then for the rest of the x-axis it did, so I went all the way out to infinity. And then for C, although you can't see it, this parabola is going to go left to negative infinity and right to positive infinity. So anywhere I try and draw lines away from the x-axis, I am going to hit the function, which means those x values are in the domain. The now try problem for example 3 is number 11. We're going to find the domain of the function algebraically and support our answer graphically. So first I'm going to think algebraically about this problem. Well, I can take any number and multiply by 3 and then subtract 1. I can take any number and add 3. I can take any number and subtract 1. The problem is I cannot divide by any number. Dividing by 0 causes errors. So any number that's going to make the denominator 0 will not be in the domain. So x cannot equal negative 3 and x cannot equal 1. Therefore, in interval notation, my x values, my domain, can be anything else, starting all the way off to the left of the x-axis at negative infinity. Continuing from negative infinity, we're going to hit negative 3 first. We've got to leave negative 3 out, so I put parentheses next to it. I'm going to start up just after negative 3, so like negative 2.9999999. I'm going to travel all the way, keep going to the right on the x-axis through negative 2, negative 1, 0, 0.1, 0.2, 0.99999, but I have to leave positive 1 out. Then I can pick back up again after positive 1 and then go all the way out to infinity on the x-axis. I will have function everywhere except for at negative 3 and positive 1. So I'm going to graph this to make sure that what I just thought about and my calculator are telling me the same thing. So, oops. Again, keep your numerator in a set of parentheses, 3x minus 1. Now the denominator here is going to get tricky because I need a whole set of parentheses around the entire denominator. So I need to open a set of parentheses for the denominator and another one for x plus 3. I'm going to close the x plus 3 parentheses, open a new one for x minus 1. And then I'm going to close the x minus 1 parentheses and close the denominator parentheses. And now I'm going to graph. And now I can see that my calculator shows me that negative 3 on the x-axis looks like a line that I draw won't pass through the function at all. Same with positive 1. I'm going to triple check by hitting trace negative 3. Sure enough, negative 3 had no y value that belongs to it, so negative 3 is out of the domain. And I'm going to check positive 1. Again, no y value that belongs with it, so it's out of the domain.